There's a quiet revolution happening in telecom networks. Forget just faster internet speeds. This is about something much deeper. It's about where your data is processed, how networks are divided, and what they're built on. We're entering a world where networks are becoming software-defined, decentralized, and intelligent, where telecom companies start behaving like cloud giants, and applications live closer to you than ever before. Today, we're unpacking three buzzwords that are reshaping the entire industry from the inside out: edge computing, network slicing, and cloud-native architecture. So, why are we talking about these three things together? Because the modern network is no longer just a bunch of towers and cables. It's an ecosystem of virtual functions, containerized apps, and distributed computing resources that stretch from massive data centers all the way to the network edge, sometimes right next to where you are. This is critical because latency is becoming the new bandwidth. It's not just about how fast your connection is, but how close the computation is to you. Applications like connected cars, immersive AR/VR, and smart factories can't afford to wait for data to travel across the country and back. They need decisions made in milliseconds. And that's where edge computing comes in. So what is edge computing, really? In simple terms, it means moving data processing closer to where the data is created. Think a cell tower, a local base station, or a small data center in your city, instead of sending everything back to a centralized cloud far away. This edge could be a multi-access edge computing, or MEC, node inside a 5-base station, or an on-premises server at a factory. Here's how it works. Imagine an autonomous car approaching an intersection. If its braking system relies on a cloud server 1,000 kilometers away, that delay, that latency could be fatal. With edge computing, the decision-making engine is hosted right there, within the local 5-cell site. Reaction times drop to just a few milliseconds. The use cases are incredible. Industrial robots communicating for real-time control, smart city cameras processing events locally for instant security alerts, or AR/VR games rendering graphics near the user to eliminate motion lag. Operators are even experimenting with edge as a service, turning the network edge into a microcloud for developers. Now, how do telcos manage all these different use cases on the same physical network? That's the magic of network slicing. Think of it like creating multiple virtual networks on top of a single physical one. Each slice is like a dedicated, standalone network, optimized for a specific purpose. It gets its own performance guarantees for latency, bandwidth, and security. For example, a healthcare slice could prioritize ultra-low latency and high reliability for remote surgery. A gaming slice would focus on minimizing jitter and maximizing speed. And a massive IoT slice could support millions of low-power devices sending tiny bits of data. All these slices run on the same 5 infrastructure but are logically separate. From a business standpoint, this allows operators to offer customized network experiences and charge for them. A logistics company could buy a private 5-slice to track its fleet in real time, while a media company could lease a high-throughput slice for a live event. It's truly network as a service. If edge computing is the ***, and network slicing is the ***, then cloud-native architecture is the ***. Traditional telecom networks were built on monolithic, hardware-dependent systems that were a nightmare to update or scale. But the demands of 5 flexibility, automation, scalability forced telcos to adopt the same cloud-native principles used by giants like AWS and Google. In simple terms, this means breaking the network down into small, independent microservices like authentication, session management, and routing that run in lightweight containers. These containers are managed by orchestration platforms like Kubernetes. The result? The 5G core becomes elastic, scalable, and programmable. Updates can be rolled out without downtime, and the whole system becomes far more resilient. If one service fails, the others keep running. This is the foundation that makes everything else possible. Let's connect the dots to see how they all work together. Edge computing, network slicing, and cloud-native architecture aren't separate ideas. They are 3 layers of a new telecom paradigm. The cloud-native architecture is the foundation, breaking telecom software into agile, containerized components. Network slicing uses that agility to carve out virtual networks on demand, and edge computing extends those virtualized capabilities closer to users, enabling ultra-low latency services. Imagine a live drone racing event. The network slice guarantees ultra-reliable, low-latency connectivity for the drones. The edge node near the venue handles real-time video, analytics, and the cloud-native core automatically scales network functions as the crowd grows. Together, they create a seamless, intelligent network that was impossible a decade ago. Let's get just a little bit technical. For edge computing, we're talking about standard servers running Kubernetes clusters right at the network edge. For network slicing, this is defined by 3GPP standards and managed by special functions in the 5-core. And for cloud-native, technologies like service mesh and GCD pipelines automate how microservices communicate and get updated. All this complex tech is invisible to you, but it's what allows operators to launch new services in weeks instead of years. We're already seeing this in the real world. Deutsche Telekom is running its 5-core on Kubernetes. Rakuten Mobile in Japan built one of the first fully cloud-native networks. And Verizon is partnering with AWS to host developer applications right at its network edge. These examples show that telcos are evolving into digital infrastructure companies, blending network and cloud engineering. What does this mean for businesses and developers, for operators? It means lower costs through automation and new revenue from services like Edge as a Service. For enterprises, it means getting private 5 networks tailored to their exact needs. And for developers, it means getting access to powerful network apps to build the next generation of low-latency applications. Of course, it's not all perfect yet. The complexity is huge, security is a major concern, and companies are still figuring out the best ways to make money from it all. But these challenges are being solved. Looking ahead to 6G, the lines between edge, core, and cloud will blur even further. We'll see AI-native networks that manage themselves and infrastructure that can both communicate and sense the environment around it. The long-term vision is an autonomous network fabric self-scaling, self-healing, and self-optimizing. The telecom industry is no longer just about connecting people. It's about connecting everything. Intelligently and efficiently, edge computing makes networks faster, network slicing makes them smarter, and cloud-native architecture makes them agile. Together, they're turning telcos into the backbone of our connected future. If you thought telecom was a legacy industry, it's time to look again because this is where the next wave of cloud innovation is happening. Thanks so much for watching. If you found this breakdown helpful, please hit that like button and consider subscribing for more deep dives into the tech that's shaping our world. See you in the next one.